All right, so we learned how to make very pretty graphs last time. We learned, once we make a table, we learned how to make a line plot, which is good for like chronological stuff, things where you want to connect the lines. We learned how to make scatter plots, where you usually don't want to connect the lines, it's just a bunch of data, like X's and Y's, how do they correspond? We learned about how to graph categorical variables, like you have to somehow find a number for each, but for each category, you can assign that number and use a bar graph. We know that. And then we were trying to get at the idea of making something that kind of looks like this, but for numerical data. For numerical data, which remember, that's just stuff that you can count, like somebody's height, age, temperature, price, stuff like that. And that brought us to the idea of a distribution. So a distribution is like, we've got some numerical data. What's the spread of that data? Like I know the max, I know the min, but like, where is it the most populated? And so we want to make a graph that kind of looks like this. Eventually we can make curvy graphs. If you make your bars smaller, they'll look more curvy, probably. We'll get to that. But yeah, we learned all these cool terms, and we were getting at the idea of a histogram. All right, so like, say we've got a bunch of numbers, and none of those numbers repeat, so we can't just like keep track of how many times we saw 188, because we only saw one of them. But something that we can do is like to figure out the relative spread of our data, we can bin them. We can say, all right, for every 5 sets of numbers, like from 160 to 164, from 165 to 169, etc., we can make those bins and put any number within that bin. We can mark it, and so we can build a kind of a bar graph, kind of like that, and that gives us a histogram. So even though these numbers don't repeat, we can keep track of like, oh, okay, this kind of range is pretty populated. That kind of range is pretty populated, and that gives us an idea of the distribution of our data. How spread out is it? Where are all of those individuals? All right. So we do have to be careful, though, when we're displaying our data, because we have a problem like this. We could cheat and lie to people if we mess this up. As humans, we consider area as like how big something is. So like this is not a 70% bigger green battery. It is a 70% wider battery, and then it's been stretched in the other dimension as well, and so it's significantly larger than 70% bigger, like Apple was claiming. It's like 3-ish times bigger, right? That's disgusting. So as humans, we see area and we think, oh, it's significantly bigger in terms of area, not in terms of width or height. All right, so we need to be careful when we're making our graphs. We need to keep that in mind. So we learned about that. And that finally brought us to the idea of a histogram. So like if you have a bunch of numerical data and you want to see it spread, you can build this histogram where you pick some sizes of your bins, right? Pick some sizes of your bins. You count how many things are in that bin. And then you need to take extreme care to make sure that the height of that bin, like from the 400 to 500 bin, the height is proportional, the area is proportional to how many things are relatively in that bin compared to the other things, all right? Compared to like the 500 to 600, the 600 to 700. So all that stuff, we really care about the area. Remember all that? So I was screaming about that, and we made that graph over here, and it seems to be happy now. One thing I didn't do is you can say the word units here. So when you're making a histogram, so I made a bunch of, where was this? How do we get this table? Because I'll probably still be working on it. We talked about, we had a bunch of top movies, right, with like titles and the studio that made them and the gross amount of money that they made in terms of just dollars. We turned that into millions of dollars. We adjusted the gross. And then we made bins for those. All right, so we can make these bins where you can get the default size, right? Millions.bin. And so the way that you read the table that .bin gives you back is it's like, this is the start, and this is the end, not inclusive of the first bin. So the very first bin is this to here, not inclusive, but inclusive of the first thing. And there's 112 things between $320-ish million and $465-ish million. And of course, you can make your own bins. It's like, here are my bins from 300 to 400, inclusive on the 300, but exclusive on the 400, from 400 to 500 in the same way. So like from 300 to 400, there's 81. From 400 to 500, there's 52. And that's how you read that. And you can turn that into a histogram and use those same bits. So like there's all that all over again. And if you want, because I did this wrong last time, you can put a little amount right here, because like the units of our adjusted gross value is millions of dollars. And so you could say that as a optional argument here. You can say unit equals, and then you give whatever you want to put there. Unit equals $1 million. And then now I have officially made the same graph. You can say the same one for here too. So like if you say .hist, it's just the same as .bin. It does the default. I'm going to make 10 equal size bins from the minimum value to the maximum value. Unit equals, again, $1 million. Then you can use either single quotes or double quotes, as you know. Python does not care. But there's that same graph. Cool. All right, so I think that's where we were. And so that is a histogram, and it's telling us relatively how many things are within the 400, 500 range, 500, 600 range, and we're dealing with area. The area tells us the proportion, all right, because that's what we as humans see. Does that make enough sense? I think that's what I wanted to say. And so now, new stuff. Let's talk about why area matters. So, okay, what I said was that the area of each of these bars, so like we've got all these bars, we'll take this and make it tiny, maybe. Here's my little graph. The area of each of these bars is proportional to the percentage that are in that bin relative to all the other bins. Like this one, apparently there's a decent amount, right? That's like maybe over half of the numbers are within the 400 to 500 range. Does that make sense how you can read that? Because it's area-based. Like take that and compare it to the area of everything else. It looks like this is almost half, right? Maybe it is about 40%. I don't know. But that means, though, that the units on this axis, which are a little disgusting, see how it says percent per $1 million? That's weird. Let's try to explain that. All right, so the area of the bar is the percentage that's in the bin, which is, well, if that's the area is the same as width and height. So we know that the width of the bin is $100 million. Like that's what we've decided. It's always that. Like we've set that in stone. So that means the height then is the thing that varies. So somehow you can make this an equation now. Like the percentage that's in that particular bin is equal to the width of the bin, which we've capped at $100 million, times the height. And so we can solve for the height. The height is apparently the percent of the numbers that are in that particular bin divided by the width of the bin. And the width of the bin, its units are in millions of dollars. The percent is in percentages. And so the units of the height of each of our histogram graphs are in percent per unit of your width. Does that make any sense at all? Like you can just solve that equation. It looks like that. And so that's why it's 0.4-ish percent per $1 million for the 400 to 500 range, which is weird to think about. But that kind of makes sense if you think about it that way, because like, okay, because we're dividing by 100, it's like, oh yeah, this is making up about 40% of all of the data we ever had. Can you kind of see that? That's how you can read it. Okay, so yeah, the height measures the percent of data in the bin relative to the amount of space in the bin. So it kind of measures the density, like how crowded is that particular bin that I'm looking at, all right? And the unit is percent per horizontal axis, x-axis unit, which is a little disgusting. Using that equation, do I want to go here yet? Yeah. Using that equation, we can kind of solve, like, we can understand why this got to be 0.4. Let's calculate. Let's calculate. And here, let me do like some dashes so that we know what happened in the next lecture. Well, let's calculate the height of the 400 inclusive to 500 exclusive bin. All right. And so what I can do is I can make some variables. So it looks like we know that bin. It's this one, right? It's all these all over again. We know that the, 400 to 500 bin is this one. It's about 18.18 or something like that. We can solve for that because that bin is from here to here, 400 to 500. So there's 52 things in it. We know that, right? There's 52. Okay, so that's a percentage we can calculate. There's 52 things in that bin. And then how many things are there total? It's just like this millions table, how many things are in it. So there's 52 things in that particular bin divided by millions.num rows, like how many things are there at all. And we can multiply that by 100 to get a percentage. So there's apparently 26% of the things in that particular bin, all right? So that's the start. And then, all right, we have to divide that to get the height, right? That's the percentage. We have to divide by the width of the bin, which is $100 million. All right. So we got the width equals 100. And so percent over the width is the final answer. And, sorry, percentage over the width is, now you kind of see, like, okay, that is, oh wait, did I do something wrong? 52% over width. Oh, I'm looking at the wrong graph. Sorry. This is the we made our own histogram. It's this one. Sorry. This is the 400 to 500. It is 0.26. That's the right one. Does that make sense how we calculated that? Like, it's all right. It's the percentage of things that are in this particular bin divided by how wide that bin was. That's how we calculate the height of our bars. And that's why the units make sense. It's like, all right, there's 0.26% per every $1 million in this bar. All right. It's a little weird to think about that, but that's how we calculate it. Okay. Any questions about that? It's a little weird. You don't really have to worry about it. Just like you have to understand how to read the graph. That's where we're going. Okay. So, yeah. Height measures density, and this is your equation. The percent in bin is equal to the width times the height. And so if you want to know, like, relatively, you're looking at your graphs, like how many people are in that bin, you think about area, like how many people are in this bin area, because it's relative, and then how crowded is the bin, like how many people are stacked on top of each other, living together in the bin, you use the heights. Like this is a very crowded bin, this 300 to 400 one. Very crowded. And it is also, if you think about its area relative to all the rest, it is taking up a decent amount. Okay, so that's how you can read it, and that's how you can think about it. So remember that. How many individuals use area, how crowded use height. And so with that, I have a question for you guys. Let's say that I messed things up and I made it look really weird. Here's another histogram with very, very weird bins. Like this one's the 0 to 10 years old, I guess. Then this is the 10 to 20, 20 to 40, 40 to 60, 60 to 100 years old. So I've changed the widths of the bins. They are no longer equal. All right. Now the question is, which one has more movies and which one is more crowded? Do we have any thoughts? I want you to think about that. I'll give you a minute. You don't have to write down your answer anyway, but try to discuss with the people sitting next to you. Which of these bins, if you can read that histogram, like where these things are important. How can you interpret this? This is probably giving away the answer, but that's okay. So try to use those ideas to answer those two questions with the people sitting next to you. I'll give you a couple minutes to ponder. So I guess this graph is keeping track of how old the movies were in this list. Some of them are very old, very popular still. Way back then, you just very push. Which bin has the most movies in it? Which one may not have the most movies, but is the most crowded? Has the most things within it? So yeah, can you determine relative area is the question, maybe. All right, our voices are dying down. Which of these bins has the biggest area? Which do we think? I think it's this one, right? We all agree? That one has the widest and the tallest. It's got the most amount in it, like compared to everything else. Like take that one on its side, turn it, like still can't compare, right? So yeah, I think that one's the one with the most movies. So 20 to 40 because that's the biggest area. And then which one's the most crowded? Like the most people within the bin. Yeah, then you start thinking about the height. Now that one's the tallest, so that means within this bin, even though it might not have the most movies, it has a decent amount of them for its relative size. So it's taller, all right? So it has more things in it relative to other bins. This one's like more spread out, even though it has potentially more movies, right? Because it's big, because it has the higher area. So I hope that makes a little bit of sense. Do you kind of see how we're reading that? So because you can mess with the width of your bins, that's why we're dealing with this area issue. All right, so that's where we're going, and that's why we care. All right, so let's see. I think that's most of what I wanted to say. So now, let me show that to you in terms of this. Like here's the normal histogram again. Normal histogram in terms of millions of dollars, where every bin was 100 size. Like you don't really have to worry about dealing with area because like it's all going to be the same width anyway. But the second you change the width, then things go wrong. So let's make some new bins. Instead of these from 300 to 1800, let's make some weird looking bins. What's the one that I did before? Let's make some uneven bins. I'll call it uneven. Let's call those, so I'll make an array from, because you give like start and end values as an array. So 300 to 350, 350 to 400, 400 to 500, and maybe 500 to 1800. So all the way to the end. So that's my uneven amount. Those are my bins. And so you read it again as like, that's the first bin, that's the second bin, that's the third bin, that's the fourth bin. So there'll be 4 total. And then you can say millions.bin with the adjusted gross column on the adjusted gross column on the x-axis, and you can say the bins are these, the uneven ones. Whee! So you can say that, and here's the counts, right? From 300 to 350, there's 32. From 350 to 400, there's 49. From 500 to 1800, there's 67 of them, but that's a very wide bin, right? It has the most, but it's a giant bin. And then you can ask that to be a histogram. In the same way, you'd be like, all right, millions.hist. Give me that. Give me that as a picture, please. And then the unit, you can say the unit again. Unit equals $1 million. So this is why we care, and this is what we want. So do you see how from 500 to 1800, this range, this giant bin, it does have the most movies. So technically it has the biggest area if you like slice it up. But it's not very tall because all those movies are really spread out. Does that make sense? Like that's why we care about this. That is a graph that we can understand. All right? Because if you didn't do that, if you didn't do that normalization where you fixed things, you can say bins equals uneven. You can turn it off for a second just for educational purposes. Normed equals false. This is what it would have looked like, right? Where, yeah, adjusted gross, how many things are in that? There's 65 things. It's the most things for this bin. And then it makes you think like, oh, there's 1 million movies over here. Because as humans, we think in terms of area. This is the correct graph to make. This is the wrong graph to make. Does that make sense to us? That's why we care. That's why we're learning about histograms, and it's all relative based on area. Okay? So, yeah, I think that's most of what I wanted to say. We can calculate all these heights. We can calculate the width and the height and the percentage if we want to, based on this binning process, if you want to do it manually, if you want to draw your own graph. So I might as well just show that to you. Let's see, what do we got? Dun, dun, dun. So we'll make these bins. Boop. So I'll make those bins, and so that gives me this table. And adjusted gross count is a very long word that I don't want to type a lot, so I'm going to relabeled column number 1, because I don't even want to type it. Let's call it count. So that makes me this. And then I'll call that, I don't know, histogram elements. So let's just like learn how to make it ourselves. Histogram elements is that. So there's my first table. And then, all right, we've got each bin, we've got a count for each bin. Let's then next determine the percentage of things in that bin, because like we want to learn how this got made, right, in code. So okay, we've got this table so far. Let's get the percentages. Those are in terms of the total count. So we need the total summed count, right? All the values here. So the total count is equal to the sum of all of the count column, right? Sum of all of the count column in the histogram elements table. So this is getting us practice with table stuff. Column count. So give me that sum, and then we could create percentages out of that, whatever the total count is. Oh, it's 200, cool. And then we can get the percentages by taking everything in this count column. We can take that all over again. And then we could divide it by the total count, couldn't we? Like, okay, that's that array. If I divide that by total count, it gives me that. So those are now percentages, right? That's pretty nice. I guess multiply by 100, you get the actual percentages. And let's add that in as a new column. So this is percents equals that new array. And then I can say histogram elements dot with a new column, call it, I don't know, percent, and it can be percents. So I just added on a new column. Does that make sense what I just did? So I'm calculating the percentages in, so that should be the area now. That's going to give me the area of all my histogram pieces, my histogram elements. And let's update the table itself like that. Let's make that the new histogram elements. Make it that. So cool, now it's bigger. And then, all right, how do we determine the height of each of the bars? We have to follow this equation, right? The height is equal to, well, if we solve for height, the percentage over the width, all right? So let's figure that out. What do we got? Well, we can get the widths of each of the bins by taking like the 350 minus 300, 400 minus 350, 500 minus 400, 1800 minus 500. There is a function for that in the NumPy library. It's called .diff. I showed that to you very briefly. So it's like, if you take that column, if you take the bin column, that's an array now. So there's that. And then you can say np.diff. Give me the differences of all the adjacent elements. So like, all right, the first one's 50, then 50, 100. That's going to be the widths of those bins, right? That's perfect. That's what I need here. So those are the bins themselves. Bin widths. So we're just trying to learn how this histogram got made for us. And then, all right, we've got those many, those are the bins. And then let's see, how many bins total do we have? Well, we have 4 of them, right? So num bins equals, how can we get that? Programmatically, we can count the size, like we can get the length of this bin widths array, or we could take the length of this original table. It's -1 though. Like this last one doesn't like have an end. So either way, like these are how many bins I have. Histogram elements dot num rows -1. So it's a little technical today. We'll get there. We'll get to cool stuff in just a second. And then, okay, what do I want? How do I do this? So let's see. We've got that, and we want to add that, don't we? We would like to say, for every, like I've got my histogram elements right now. That's my table that I have right now, and like to attach to it like a width column. All right, so we've got, what is it? We've got these bin widths right here. I like to kind of attach that, but I only have 4 things. I only have 4 things. Oh no. So let's maybe get rid of one of these. I think that would make the most sense. We can get rid of this last one by taking only the first 4 rows of the table. So because then we could attach an array of size 4 to the rest of those. That's something we could do if we wanted. So okay, let's take, so histogram elements, only give me the first 4. You can say .take to take just a few, and you can say, you can give it an array of like which indices do I want? 0, 1, 2, and 3. That would give me just the first 3 things, but we can make this faster with an arange. Be like, all right, np.arange, go from 0 to 4, oops, and close it off. That would be faster. You can go even faster. If you didn't know how big it was, you would say take it up to just like from 0 to num bins. That would work as well. And then the default is 0, so you could have just said array up to num bins. That's me taking just the first 4 things in a bunch of different ways. And then I could attach now my num bins. Width column. We've got width, and we'll call that, we'll put bin widths there. So there, okay, now I have the widths of each of my bins in my histogram, and then I can now, with the percentage and the width, calculate the height of each of those bars. This is what's going on deep down inside of Python land when they're trying to make your histogram for you. And then, okay, we're almost there. Let's get those heights. Let's add them. So let's actually call this one histogram elements. I'll update it. It equals that. Cool. And then let's attach one last column, which is the height. All right. Oops. That's what happens when you do it backwards. So I need to do this all over again. Play that one, play that one, play that one. Okay, now it's happy. So I've got all of these percents and widths. And now I'd like to attach a height column by taking the percent column and the width column and dividing them. That's all I need. That's the final answer, right? So I got histogram elements dot, give me the column for percent. That's that array. Give me the column for the width. That's that array. And if you divide 2 arrays, it will do a calculation for you. So we want percent over width. So I'll do a slash. And there it is. There's going to be the heights of each of my histogram elements, each of my bins. All right. And that is going to be attached. That's the last thing. Heights equals that. And we got some ugly looking numbers. So a nice thing to do is sometimes to round. So let's take this array and be like np.round it. NumPy takes an array and rounds everything. So there's your array, round it, comma, bless you, 2, let's say. Round it to 2 decimal places. And so that might look a bit cleaner. That's what heights looks like now. That's a little bit better, maybe. And then I want to finally attach that array, because it's a size 4, attach it to my existing table. Finally. So histogram elements dot, put it here, dot with a new column. We'll call it height, and we'll put heights there. Ta-da! So finally, we have made the same thing as we made here. So take this all over again, look at it one last time. That's kind of what Python's doing when it's figuring out, all right, I've got the width. What is the height that I need for each of these? So this is relatively not very high, 0.03 height. This one is 0.26 high. And so that's how those calculations get done. And now you can never forget. All right. Any questions about that? That was very technical. But I hope you kind of see why. Like, we really care about area because that, to humans, like, it's a huge difference between these two graphs, right? And that's the key. All right. I think that's most of what I wanted to say about histograms. Are there any questions about that? All right. Okay. Yay. So that makes everything nice. So now we kind of have a choice. Sometimes we know that histograms look a whole lot like bar charts, right? These guys. So the question is now when to use one over the other. So bar charts are usually for categorical variables, right? So you've got a distribution, you want to show it over a categorical variable, like all of my ice cream flavors, I've got an amount in the back, all right? And each of those bars have just whatever width you assign to them, but they're all going to be equal, because like you can't have like half of vanilla over here, a range of vanilla that way and that way. Like you can't split up something that's categorical. It's like it's already there. Like the color, you can't split up red, orange, yellow, whatever you already have. Okay, it's just like whatever height, whatever things you have. Like you pick a size and it's the same width for everybody, and then the height shows you how many things you have. So it's already like based on area by default. So it's kind of easy. Yeah, it could be in any order because like it's categorical. Put it in alphabetical order if you want. Put it in rainbow order if it's colors. And yeah, the height and the area is always proportional to the percentage because it's always going to be the same. For a bar chart, you're not going to ever make, for some reason, the width of the chocolate bar shorter than the width of the strawberry bar. You would never do that, all right? Whereas for histograms, you totally would, all right? We've seen reasons. You maybe want to split things up in that way. So that's something we care about now. And a histogram is for distributions, not of categorical, but of numerical variables. We want to be like, how much is within this range? How much is within this range? We're going to make bins, all right? And then, yeah, the horizontal axis is numerical. It is to scale. You should not put gaps. You can have unequal bins, but you shouldn't be like, don't like erase part of this graph or something, because that would, again, confuse people because you want to deal with the areas, all right? That's what we care about. So the area of your bars is, again, proportional to the percentage of the things you have, the individuals in that bin. And then the height is not like a count anymore. It's a density, all right? It's like how crowded is that bin, because this was a wide bin. It did have the most movies, but it's not very dense. Not very dense because it's so wide, okay? And then the unit's weird. We've talked about that. So that's pretty much all that I wanted to say about histograms. Do you see like the difference? So it's categorical versus numerical. Got to remember those words. But once you do, you're golden. All right. You ready to try something yourselves? All right. So we have some wonderful, wonderful tables, right? That we could make. Let's go back to the Titanic data set. So again, if you want that, you can drag it in. I'll show you again how to do that. Boop. That's up here, right? If you want to just quickly go to a Jupyter Lab instance, you can click that link. And then also, if you want the table itself, so we got to get the Titanic data set that's in our code from class. Let's actually keep that there. Code from class, it's in the data folder right there. And it is legitimately titanic.csv. Click it, and you can download that, and then you can drag it into the files here if you want to work like this. So get the Titanic dataset, read it in, remember how to do all that. And I'd like you to make 2 histograms, please. One for the survivors, the Titanic survivors. So you need to do maybe a .where, right, on your table. Get just the survivors and try to make some bins. You can use the default bins, that's fine. But let's see what it looks like in terms of age, because I have a feeling like they probably prioritize the children, right? Let's see if that shows up on the graph. So for the Titanic survivors, see what age they were. And then it should maybe look a bit different, like the graph should look a little bit different for the non-survivors. Do the same histogram, but for the people who did not survive, what did their ages look like? And you can come up with any bins you'd like for their age ranges, like go by 5s if you want, go by 10s if you want. You can use the default, it's going to make 10 evenly spaced ones from the max to the min, whatever you like. But see if you can figure out, like, what did it look like? See if you can glean any information from the data. Does the question make sense? Go forth. Try to make 2 histograms, one for the survivors based on their age, and one for the non-survivors based on their age. And let me just quickly show you the code that makes a histogram. It's .hist. So you can give your bins if you want. If you don't give the bins, it'll make its own little default 10 bins. That's how you do it. Okay? So yeah, I'll give you a few minutes to try that. I want to see if it works out. Maybe like 4 minutes, let's say. And that's going to be table.read table. We have not memorized that yet. Table, and then split, right? You want a table of just the survivors. So you're going to probably have to do a .where survival is 1. That's also an interesting case of a column being numbers, but also categorical at the same time, because 0 means no and 1 means yes. They're using those to mean a categorical thing. Right? It's not really something you can do math with. Hmm. Give you another minute head start. Are there any questions as we're trying it? Like, is it working? The very first step is get the passengers to survive. 4 minutes survive. Then you could get fancy after that. It's like, all right, how about the first class passengers? How old were they relative? Second class only. Third class. You can split it. Make several graphs. Could be women versus men. What were their ages relative? Very cool things you could ask. Question?
I think it's so important because it's not thinking
Oh, yeah, that was an array that I made myself. So you can make your own bins with like np.a range, so you can make your own, or you can just not say bins equals anything at all, and it will just be the default 10. Yeah. All right, that's my head start. Let me try it. Any other questions came up as we were trying it that I could answer before I do it? So here's how I'll think about it, I think. I'm going to get the table itself, Titanic, by reading it. Table, read table. It's in my data folder, it doesn't have to be in yours. Titanic.csv. So there's my table. And then I want like the survivors and the non-survivors. Apparently it's called survived rather than survive. I'll have to update this. This is the old one. But survived, we want to get those ones. Okay, so Titanic dot where the survived values are equal to 1. Something like that. Or you remember that this is default, so like you could just said survived as 1. Either way, I'll do the long way so you can remember that. But there's a new table, right? There's the survivors only. Survivors. And we can do also the non-survivors in the same exact way. Might as well do them right here. Non-survivors. So that's where it was survived was equal to 0. And then I can do histograms on those. Be like survivors. More or less just say that. Survivors dot hist. And you just got to say what column you want to do it on. And it's age. You say it, I want to do it on age, please. That's my x-axis. And it will just by default make those 10 bins for you. If that's all you care about. And it looks like the min was like 1-ish. And the max was like 80. So it kind of made some normal looking bins. But if you didn't like the bins that it gave, you can make your own. Be like, all right, my bins that I'd like to have here. Like, all right, what are my survivors? Survivors, or just let's look at all the Titanic passengers. Let's look at the ages for those. So get me the column for age. And like, what is, some of them were nans. We didn't know their age. What's the min? The min is like, I guess they did it in like months probably. So the min is like a little over 0. So you can't have a 0 age. And that was the max. 80 exactly. All right. So it looks like 0 to 80, those are good bins. So we can make those. You could say bins equals, like we could make a np.a range from 0 to not 80, it's got to be like 81, right? Going by, you can go by 10s, go by 5s, I guess. That's a different one than the default. I'll now have 20 bins, right? So cool, there's your range. You can have it as precise or as imprecise as you want. So the bins are 5, it's like for every 5 years old of age. This is for every 10 years. I don't know, we can go by like every 7 years. Doesn't really matter. But it should probably add up properly. So let's do by 5s. Cool, so there's the survivors. It looks like they did like the children. They did keep a lot of those saved, which is good. They maybe preferred them. What about, how does this now compare to the non-survivors, right? With the same kind of amounts. It looks like, yeah, on average, You see the stark difference. It looks like they did prefer the children, which is a good thing, right? That's the moral thing to do. They tried to save the kids. So more kids survived than didn't survive, which is nice. And it looks like the rest is probably just like the rest of that graph is just kind of like the age spread that there was anyway, right? Just like of the passengers, probably a decent amount of them were like 20 to 40. And you can compare that, right? You can ask for a histogram of every person, survivor and non-survivor, on the Titanic itself, right? Just like the whole Titanic. Give me those bins. This is what it looked like. How does it match? So like, where are there differences? This is everybody on the Titanic. You kind of see how like the non-survivors kind of looks the same. So we can maybe say that just like kind of randomly people didn't survive. They kind of looked similar, and you can see that there's a difference. There's a difference in the graph of the survivors, especially among the younger ages. So that you can see that, okay, it doesn't match the original anymore. So that probably means they did prefer like putting the children on the lifeboats first, something like that. And so that's a question we can answer. Isn't that cool? Are there any questions about how I did that? How I thought about it? I think that's fun. All right. Let's see. I do want to show you one more thing before I give you one last thing to try. There's like a new little section we could have here. I want to talk about like putting multiple graphs in one graph. That's called overlaying your graphs. Overlaid graphs. I don't really have slides for that. It's just like, it's part of the stuff. So like, I wonder if that's on our documentation anywhere. If you look at these, like .hist or like, yeah, here we go. Like a bar chart. If you happen to have multiple columns, so like this is your categorical thing when you say bar H. If you had multiple numerical columns, it would put each of those next to each category. So I just, like when I made my bar chart, I didn't have anything else. But if you had other things, like you could add things along. And the same is true for like scatter plots, and also by year plot things. So let me show you how that all works. Overlaid graphs, like you're putting multiple graphs on things. I got some interesting data for you. So table.read table. This is something from the book. We've got a data set called sun's heights, which is an interesting one. And what they did to calculate this table, to generate it, is they just, like, I guess they did a survey of a bunch of different people who had sons, apparently, and like they took the height of the father, the height of the mother in terms of inches, and then also the height of their son, probably at a certain age, maybe like once they stopped growing, I don't know. But you can scatter based on something, all right? You can say sons heights dot scatter, and if you say somebody you want on the axis like sun, because there's two other numerical things, it'll graph them both with different colors. Isn't that cute? It's like sun, the height of the suns is on the x-axis. So like for a height 70 sun, like the tallest father in that category was a little over 70 inches, and the shortest mother in that category was a little above 60 inches. So you're getting both in the same graph. Does that make sense? It's like you had two columns after this one. You had two other columns that had numbers in them, and it's just going to treat those as separate data points. Like this is now, sun is always the x value, but the y value is every other thing, color coded. Does that make sense? It's like that's a thing you can do. It's kind of cool. Let's see, if I want to do an overlaid one of these, then we need some data. We need some chronological data that we have multiple different instances of it. So let me show that to you. There is a nice other data set. So like I just have a bunch of examples called. So this is for like a line plot. If you want to do something like that, it needs to be chronological data. There is there's a census table. Census estimates from 2010 to 2019. So you don't have to, I just have a bunch of mini tables to use here. But what this table is it's got a bunch of population values from like the 2010 census, because we do it every 10 years in the US. And then they have some estimates of the population after that every year, because like you can do math to see like how is the population going to grow in between the time that we take censuses in this country. So like here was the exact census 2010 population, but really some people didn't respond, and so like there's the real estimate of 2010. Here's the estimate of 2011 population among a bunch of ages and sex combinations. Like for 0 might be male, 1 might be female, and like age 0 there's this many people in 2010. Age 1 there's this many people in 2011. That's what they're estimating. Okay, and so let's see. I want to show you something I need to teach. That I'll teach you later, but you can ask like how many things, what are the different amounts in each of these categories. So like the sex categories for gender, let's talk about those. Census dot, there's a dot group, and I will teach that to you in detail later, but let's group by this, and by default it gives you the count. There's also sex 2, which is just like I think that's just both. Like, what's the estimate of both? So it has an estimate for people age 0 of every gender, 0, 1, 2, all the way to I think age 100, something like that. So yeah, let's do that. And what do I want to think here? Or actually 1 and 2. I think it's 1 and 2 that are male and female, and I think 0 is just everybody combined. So if I remember that properly, yeah, that's how that's going to work. And by the way, this sex variable, it is categorical. Again, even though it's a number, just like the survival, right? It is a categorical variable, even though it's a number. So you can use numbers in non-numerical ways. Remember that. All right, so let's, I don't know, let's get age estimates of children. So age is like 0 to 18 or something. So let's say all the kids in the census are, all right, all the census elements where the values for the sex column are equal to 0, so that's male and female, all the genders, where also the age values are below 19, so all the children, I guess, including the 18-year-olds. And then, so that gives me this. A lot of people. And let's just get out a few estimates. Let's be like kids dot select. Let's get their ages, and let's get their estimate for 2010, like the population for that age in the country, and then we'll do the same for the estimate in, I don't know, a few years later, 2014, let's say. So that would give me this table, and so like there's some correspondence. Maybe we'll graph it. So now I have 2 chronological pieces of data. That's all I'm trying to say, right? In 2010, 2014 for different ages. So let's see here. So let's say kids is that now. And then also, just to make things easier, we can relabel these columns because pop estimate 2010 takes lots of typing. So you can say kids equals kids.relabeled, and you can say, if you want to relabel a bunch of things at once, you give all the names in an array, like make an array of all the names you want to relabel, like these guys. And then you give another array of what you want them to be called, like make array. I want those to be called 2010 and 2014, please. There's little tricks you can do like that. And I think that's fine. And so there's, for each age, here's the estimate in 2010, the estimate in 2014 of the population for that age, all right? And so all I wanted to do that for was to do a plot. So kids.plot based on age, because that's also chronological, right? People getting older. And there it is. So I had two different columns, 2010 and 2014, and those are all also there. So that's how you can do an overlaid graph, and you might want to do it for that. Kind of notice how, kind of makes sense, right? The 2014 graph is kind of the 2010 graph moved over by 4 years, because all those kids got 4 years older. Does that make sense? So that's part of the estimate, but it's also getting a little bit bigger. So like it went that way and also up a little bit because like immigration. So that's pushed over. It's almost the same graph pushed over by 4 years, and that kind of makes sense if you think about it. Cool. I like that. Yeah, that's kind of what I wanted to say. You can also do an overlaid bar graph. Let me do that with Pokemon really quick. I want to show you something really weird. So I'm just going to copy and paste it. Let's see. Where do I want to go to get to that, though? Probably here. So I have a secret file that I'm using to copy from. So a cool one, we could use it with Pokemon, but it would take a lot of typing. So let me just copy and paste it. Desktop. So in my little practice folder, I made one for chapter 7. And if we include the Pokemon table really quick and do something weird with it, I can show you a bar chart for those. So let's include the Pokemon table. So there's the Pokemon. And then let me do something really odd. Boop. And then I can do a bar chart. So here's what I've made with some weird code. You can stare at this later. I can tell you what it means one day. For every type of Pokemon, I've counted like how many bug type Pokemon were in Generation 1 Pokemon, or in the Generation 1 games, Generation 2 games. And so that's, all right, for each type of Pokemon, what was the relative amount that appeared in each of those generations of the games? So you can say gen types dot bar h and make type 1 the categorical variable that we're drawing things with. So you make a cool looking graph like that with a bunch of pretty colors. And so it looks like there's always a lot of normal Pokemon, there's always a lot of water Pokemon, but especially in Generation 1 and Generation 3 for water, for example. And you can see that in Gen 1, the steel type did not exist. There was 0. So stuff like that. That's an overlaid bar chart. All right. Any questions about any of those? It's just like if you had another column or multiple other columns, those would get displayed as you said dot scatter or dot plot or dot bar h. So just things that you can do to make things pretty and have it all there for you. Okay. Any questions about any of that? All right, so yeah, I want to give you some time to play with a different data set. Let me just teach you the last few things of this chapter that I need to teach you, and then we can play and see what comes up. Miscellaneous things I need to teach you now. This will be necessary for like a lab or a homework. All right, so dun dun dun. At the start here, I did all this weird stuff, and I kind of explained it. Let me do it again. So when you say this stuff, boop, this first one is saying like every graph I make displayed immediately. Don't like save it as a PDF or something somewhere else. Like I want to see it. This one imports something that you could use to draw your graphs. Like this is the actual thing that like when you say dot bar h or something, dot scatter, it's calling out to this thing called pyplot. That's how it's secretly making its graphs. And most people import it as PLT, but your book likes to import it as plots for some reason. So like, I'll just say that now. Your book imports it as plots, but everybody else I know imports it as PLT. It could be anything. So you'll see both. And then this is like, use these colors. It's like a color scheme. There's different options, and this is like something other than the default. So that's what that means, again. And if I made a silly graph, let me make up some names. So let's make a blank table with a column called X and just a bunch of values in it. Make array like 1, 2, 3, and then I'll do a Y column because I want to graph this. Make array like 4, 5, 6. So there's a silly table. I'll call it T. So just a very odd little table. X's and Y values, I want to graph it, right? So you can say t.scatter, of course. Scatter with the x-axis being the x column. And it would draw it like this, and it would kind of spread it out as much as it can, right? Where it like kind of comes up with the widths of these and like how spaced out they should be. Like it decided for some reason by default to go by 0.5s. And then same for the height. Like it went from the min to the max, and like it decided to go by 0.25s. You can change those things. All right, there's a way, but you have to go through this pyplot stuff. So you call it whatever you want, call it plots, call it PLT, and then you can mess with your axes. All right, so I want to show that to you. So if you make your graph, like you still got to say like, I want this graph made, please. And then after you say that, you can start messing with plots. You'd be like plots, dot, you know what? I would like the y limits, dot ylim is how you say it, to be like between -5 and 10. I would like the x limits to be between -2 and 20, something like that. And then that would update how it makes the graph for you. You see how that got made now? It's like that one versus that one. So you can change it. you can change it. You can also change like how it determines to go by fives. Like that's another thing you can deal with. There's that. You can also change the title of the graph. Be like plots.title. So this is dealing with the plots that we're making in this particular cell. Dot title, like whatever you want it to be. And so that puts it up there. You make a pretty graph that way, and you can export, like right-click it. You can save it as something. Okay, so that's how you can make your graphs. But you always want to start with a thing. So always make your actual graph first. Make a graph first, and then you add stuff onto it. Like, all right, then put stuff on the graph next. All right, and so that deals with all these. And then you remember that when you do something in a cell, it will produce its output, of course, and then also the very last line will give its answer back to you, right? The very last line will give its answer back to you, and apparently .xlim, what it does is it gives you back whatever you just put into it. So it's also going to say that, in addition to making your pretty graph. And you probably didn't want to see this part, did you? Like you just wanted to use that to control how the graph got made, right? So what you can do is, it's going to feel weird to some of you who've like learned C++. You can put a semicolon on the last line of your cell to have it omit the output of that last line, because by default it would have output whatever it became. So a semicolon here prevents that output, prevents the default output of the last line, which is usually what you get. Like, no, I just wanted the graph, actually. I just wanted the effect, please. And that will make your pretty graph with your axes and your title, and there's more where that came from, and you'll read more about it. All right? Any questions about that? So just like, we make pretty graphs in this chapter. You've learned all the different ways, and like here's how you can spice them up a little bit. All right, you ready to play around? All right, that's what we save time for. That's the key. So what I'd like to do now is let's go back to like a simpler data set where we have just a few things. Let's look at our serial data set. So please get that included, and however you need to get it included. Like we got our serial data set with all these different. I think it's actually like the data set was published in like 93, but it was really created in 89 or something. So like at least a lot of these still exist. But we got all these things, and try to, let's see, do I need to, maybe I should include what the columns mean again, just in case we forgot. What I'd like you to do, let me open up that set of slides real quick. So I think it was here where I gave you what those were. Here's the columns of the serial data set. We'll go to that in just a second. I'll put that on the screen. But what I want you to do is kind of what we did last time. It's like, all right, we have a data set. We have a bunch of columns. Here they all are. I'll tell you what those mean after I explain. I'd like you to, as a group with the people sitting next to you, say hello and try to come up with some ideas of things that you could like do here. So please try to write those down. I'll go to the written nice page. You can elect a leader to write down your ideas. I'll clear them out. And like try to write down like what are some questions that you could ask and answer with a visualization. Like what are some visualization ideas for our serial data set? And like I want a bar chart here. I think a scatter plot would make sense here. I think a histogram would be cool to see these ranges for this particular value. Stuff like that, all right? And then we'll pick some to do, and I'll let you try them for a little while, and then I'll also do them too. But please first write down your ideas so I can see, all right? So yeah, just kind of like last time, write down your ideas. I want to give you some time to try them and ask questions and see like if you can make them yourself, because like that's how we learn. And then I'll also do some too. To try to answer those questions and just to have it all preserved for later. All right? Does that make sense, what I want? I just want you to play around with all the things that we've learned. A page that you could probably be on is this page that is right here that tells you all of the reference stuff. You can also look at the slides from last time. It has all of these slides mostly. And so all that stuff is there. Even though today's slides are not posted, it's the same slides from last time. So yeah, give that a try. Write down your ideas, please, and then try to achieve your dreams. And we'll talk about how to do it after all that. So here are the columns themselves, and yeah, take some time to think of like some visualization ideas, write them down, and try to make them too. All right, we got plenty of time. I'm gonna ask lots of questions. I'll give you a few, I'll give you like 7 minutes to try all that, and then I'll come back and we'll do them together. So read in that table and then bar chart is for we got our categorical things. We got for a line point. You need chronological things for that, so maybe a line pop over. And years or scatter plot would probably make sense. Something versus something else. Then histogram for sure. You got a bunch of numerical variables that you could deal with. Do shout out if you have any questions about anything as you're trying it. I'm here to answer them. Oh, that was fast. Another few seconds to keep working. You keep working when I come. Bring us all back. It appears my timer is about to expire. Oh, so loud. All right, I would like to look at your ideas and see, and pick a few to try, because I think you have some good ones. Wee, nice. Let's try some of these, and we've had to like figure out like what kind of visualization do I want? Do I want a bar chart? Do I want a histogram? And then like what do I want it of? It's like it's a multi-part kind of question to be thinking about these things. That's great. Are there any questions that I could answer as we were trying this? Did it all make enough sense? If we had more time, we could do whatever we wanted. I believe it. So let's try some of these. Yeah, we can get a histogram of vitamins per manufacturer. Oh, I like that. You might have to use something that I haven't taught you yet, but that seems kind of cool. What could we do? We could split it by manufacturer, sure. And then we want like the total amount of vitamins or the range maybe. Let's figure this out. Let's explore. We can do table stuff before we do visualization stuff, but I like that. Let's think about these things. So I will read in the serial.csv file. So I don't think I've done that yet in this place. Serial equals table.read table data/serial.csv. And so there's my table. And we got a bunch of different manufacturers, right? So we got, I forget what these all labels K is probably Kellogg's. We could split by those, and we've also got the amount of vitamins. And what this value means, I think it's always a certain number. Let's see, it's got a different range. The vitamins are either going to be like they've added no extra vitamins, they've added 25% daily value of vitamins, or they've added 100% daily value of vitamins. And so we could totally graph that in a histogram, but honestly, it could have also been a bar chart. Couldn't have, because like it's only these values, sadly. So that's weird to think about. So like the ranges wouldn't be that kind of interesting, but we'd have to cut it off by 3 for sure. So like if we made any histogram in all of vitamins, if we know there's only 3 values, so we got, what do we got? I just did serial.hist on, like for every serial ever on vitamins. It's going to try to make 10 bins still, right? And technically, I guess it's showing you the ones. Like it's showing you like, okay, here are the ones with 0. Here are the ones, you have to read it that way though, wouldn't you? Here's the one 0, here's the ones with 25, here's the ones with 100. It looks like most of them are like slightly fortified, not completely. Which would make sense, all right? And then maybe some manufacturers are better than others. So I think the answer that I could show you right now is there's a cooler way to do this, but if we really did want to split by the manufacturer, one thing you could do is just like select out each manufacturer themselves. Be like serial dot where the manufacturer column is equal to K for Kellogg's. That's MFR, sorry. MFR. It looks like they either went all or nothing. They gave you all the fortification or nothing at all. So that's kind of interesting to think about. So yeah, you do have to watch out for like these. Maybe these bins are not good bins as well. Like, all right, if we know it's only between 0 and what is it? 0 and 25 and all the way to 100. You could make your bins different if you wanted to. You can make 3 bins, or you can make like a bar chart probably. Could we have done that? Would it have just worked? No, sadly. It's like, no, it's because it saw that it was numerical, even though it's kind of like a categorical thing. You couldn't have made a bar chart, sadly. You had to do a histogram, alas. There's a way to turn it into a bar chart if you really wanted to. But we could also just be like, the bins, you know, and I don't want the defaults. I want to make my own. So make an array of like, I don't know, 0 to, because we know it goes up to 25. There's that one, 0 to 25, and then 25 to 100, and then like 100 to 101. I don't know. I don't know how we want to think about that, because the last one's going to be a little weird looking. Oh, sorry. You don't want this one here. So you could think about whatever bins you wanted here, and that would look a little wrong, probably. But that's another thing you could do. Probably the default, even 100, like spaced out by 10, kind of makes sense still. But you could also think about your own. So I like that. If you wanted to split by manufacturer, there is a way. You could use that dot group thing that I haven't fully taught you yet. I've shown you it a couple times. But you can be like, all right, for every cereal, I like to group it by manufacturer. And then what I'd like you to do for each manufacturer is not make a count, but do like give me like the average amount of vitamins. And I'd have to look that up because I don't remember how to do that. But there's a way. Like you can group by a certain column, and you can get a value there. So do it by np dot mean or dot average, and then it'll give you like what is the for each manufacturer. It'll split it down for each manufacturer. What is the average amount of vitamins? Like that could be a thing you care about. It's like that. That's something, and you can select out just the one for vitamins. Like select out the manufacturer, and then also the vitamins average. So those are the ones we care about right now. Like this would probably be how I would do it, but I haven't really taught you how to use the dot group yet. That'll be next slides. And then we can do a, I guess this would be a bar chart, wouldn't it? Because manufacturer is a categorical thing. So dot bar H on manufacturer. I've got a numerical value for each manufacturer. It looks like General Mills and Kellogg's. Those are the ones with the most vitamins on average. Interesting. Among what we have in the data set. Does that kind of make sense? How you can think about that? Like that would answer my question. So a bar chart was the answer there. Let's look at some others. Have you all done attendance, by the way? Please do that if you haven't. We've got, all right, manufacturer versus the amount of sugar. Interesting. Yeah, maybe we can, that's exactly what we might be able to glean from that. Maybe like that, if there's more sugar, that means they like to market themselves to kids. That's really cool. So let's try that. Manufacturer of cereal versus the amount of sugar. Again, you could maybe play the same game of the grouping. If you didn't know how to do that, you could just like split them all out and get the numbers first, make your own table. But there is a way. Let's group by the average of all the things based on the manufacturer. Again, that gives us this. And we could select out this time the manufacturer as well as, is the average a good idea here? Yeah, maybe. Average amount of sugar, that would make sense. So like average, sugar is average, is what it got called then. Sugar is average. And so there's those for each of them. And again, you could maybe do a bar chart. Bar H on the manufacturer as the categorical thing. And it looks like, ooh, whatever this one is, the P. What is that one? Ralston Purina. No idea if they still exist. Maybe they've changed names. But they had a lot of sugar for some reason. Interesting. Same with General Mills, Kellogg's, plural, sorry. And then, interesting, R for that one. P, oh, sorry, P is Post. Excuse me. All right, I guess Post, those, what do they make? They probably make kids stuff, right? You'd be like, all right, what's P now? Cereal dot where the manufacturer is P. What kinds of cereals were there? Interesting. These, I mean, in their names, they look like they're healthy. Interesting. That's, I guess, they add sugar to make it taste better, or it's like you've got some like fruit that's in there somehow that could bring up the sugar amounts, but still potentially be healthy because it adds fiber and stuff. So cool. Now we know. So that's a great question. Any thoughts, questions about how I'm thinking about this stuff? Because like that's what I want to get across to you. Like, I want to make sure you understand what I'm doing to answer these questions, and maybe that's what you came up with. Whee! What else? What else? Let's do one of these ones, and then if we have more time, we can go back to the others. Protein amount in cereal with less than 100 calories and correlation between sugar and rating. Ooh, I like, let's see, protein amount and sugar. So I think that this one could maybe be, we could turn that into a histogram. This one could be maybe a scatter plot. I think that would be a good one for a scatter plot. Let's try both of those. Protein amount in sugar in cereal with less than 100 calories. So, all right. And I assume calories is like in a serving size. So like, let's get the cereals where the calories in a serving, the values there are below, right? Below 100. That would give me only a few cereals. And based on those cereals, what are we trying to do? Let's get the protein amount. The protein amounts. So let's get, let's select out the, let's see, what do we want? We really just want the protein. I guess we want the name and the protein. Is that all? Or it's really just a histogram on the protein. Something like that. I think that would do it. So they are a little chunked up, but these are the amount. I think they probably only go by like in intervals of 1 gram of protein, 2 grams exactly, 3 grams, but this still picks them out. That's kind of cool. It looks like when there are below 100 calories, there's like a, I don't know, a medium amount of protein. I guess 2 grams is the most amount there. The highest amount of, what is it? The biggest area, right? So the most individuals in that category. It's also the most packed category because it's the tallest. It has the highest amount of density as well. So that's a cool question to ask. And then correlation between amount of sugar and rating. So that just screams scatter plot to me. I've got an x-axis thing and a y-axis thing, right? So let's try that. Sugar and rating. And I mean, the question now is which one should be on the x-axis? Which one should be on the y-axis? It's up to you. We can try both. Cereal is, so we've got sugar and rating. Are they just called sugar and rating? Sugars and rating. So sometimes it's singular, sometimes it's plural. I think that's the scatter plot. Scatter, do sugar, maybe sugars can be on the x-axis. And if we want just the rating on the y-axis, we can do, let's look at the documentation. If we ever forget, we can always come back here. You can give the name of the y column. If you don't give the name, it'll just try to graph every other numerical thing. So sugars and rating. Whee! So it looks like as the sugars increases, the rating decreases. Again, I'm not sure where this rating is coming from, but not coming from kids, maybe from Consumer Reports, like a rating of maybe the rating is how healthy it is. I don't know. So we don't get any more data than this. I'm not sure what the rating meant, but apparently, with the fewer amounts of sugars, the rating was higher. Odd. So yeah, still I'm not sure what the rating meant. It was like rated by parents or something. And again, you can change the axes. Like rating could be the x-axis. It's up to you. Sugars. Maybe that's more interesting to you. So like, okay, yeah, if, for higher ratings, it's lower sugar. Again, it's the same view into this. It's just like the axes have been flipped. Still, you see a decrease as things increase. It's a negative correlation. Remember those words? That's kind of cool and weird at the same time. But now we know. So any questions about how we're thinking about this? Like that makes sense to be a scatter plot. I've got two things I want to graph relative to one another. One's on the x, one's on the y. So there's those. And then, yeah, we should have time to do all the others. If you have more ideas or have questions, please shout them out. But let's do this one. Ratings versus weight. Oh, nice. Popularity, like maybe it's more filling. You think that like if it's more filling, maybe like in terms of weight, then you'd be happier, you'd rate it higher. That would make sense. Yeah. Popularity takes consider like portion weight, portion size. Let's see that one. So I think that would probably be another scatter plot, right? I think that would be a scatter plot of, again, I need to remember the names of things. Be like, let's scatter on, we've got rating and weight. So rating is that one, and then weight is that one. And again, you could go in any order. I don't know. I kind of like rating on the y-axis for some reason. Just in my mind, that makes more sense to me. But maybe it doesn't to you, and you want to do the other way. Interesting. It looks like a lot of them are like, you get 1 unit. 1 cup, I guess, is like the default. Maybe that's what it is. Oh, 1 ounce. Or no, yeah, 1 ounce per serving. It seems like not a lot, but we never know. We don't know. It looks like most of the cereals, like that's their serving size. They set it at that, which is kind of interesting. Maybe everybody wants the same amount of cereal, regardless of the calories. But like that's taking up most of the room there. But it looks like if it's smaller versus bigger, I guess when there's more weight, the rating does go lower, it seems. Like relative to the smaller ones over there. But like, I don't know if you could say much from this graph, honestly. It does kind of see like the smaller weights over there higher rated than the larger weights, but everybody's kind of like in the middle a little bit. Like you can kind of see like maybe a downward trend. Who knows? Who knows? That's odd to think about that. All right, when there's less weight, the rating, again, I don't know what the rating is saying. Either they liked it or like they were rating the healthiness of it or something. Again, this would make sense if it was healthy. Like, all right, you're eating fewer things. They did care about health in the 90s. But that's a cool thing to think about. You do have to worry about this kind of stuff when you're dating. Like you have a bunch of stuff capped at 1. Like what does that mean for you? You have to somehow determine if that's useful or useless information to you now. That's kind of cool. Yeah. Any other thoughts? You write anything else down? Or any questions about how we were thinking about these? So we did a scatter plot. We did some histograms, which had not a lot of values that were different. Let's do like a histogram of things that seem to differ a lot. Like let's do sodium. Sodium seems like a value that's all over the place. Let's do a histogram of all the sodium in the cereals. So do it on sodium, please. That kind of seems more normal. It's like some of them have no sodium at all, maybe, or just a little bit, up to, I guess it went by 25s, kind of. And if we're not sure what these bins are, you can say dot bin. What are the defaults? It went by 32s. Weird. If you didn't like the default bins, you could be like, I would like, instead, to use the following bins. Let's do np.arange. Let's do it by, I don't know, 25s or something. Let's do starting at 0, going to whatever the maximum is, which I don't know yet. I'll have to figure that out, question mark. Going up by 25s, though. Like maybe that's a normal amount. And so how can we get the upper bound? We can look at this here if we wanted to, but we could also be like serial.column sodium. That gives me the whole array, and then you can get the max of that. Like, okay, it goes up to 320. So if I'm going by 25s, I want to go up to 325 probably. That would make the most sense. And like if those are my bins, that's how that looks. Slightly different. Cool. Looks like nothing's between 100 and 125, which is odd. So maybe we want to go by more than that. But that's close enough. All right. That's kind of cool. We can go by 50s, I guess. Go up to 350. Maybe that's not enough bins. I don't know. It's up to you. Use the default, make your own. But that's an interesting histogram. We did that one. We did a few bar charts, right? So splitting up by manufacturer, because manufacturer is just a name. It's a categorical thing, right? If you wanted to. And remember, something that you could do to these bar charts is you could sort. Like if you don't like it in this default alphabetical order, you could sort it and be like, oh, you know what? Instead, I would like you to, in the middle, before I do the bar chart, do like a sort on, what's it going to be? I guess it's called sugar's average for the column we care about. So sort by that, please. Sort by sugar's average descending. Descending equals true. Or was it ascending? I don't remember. Something like that. And then this is kind of all over the place and it's hard to read, so I can make multiple lines maybe. Sometimes Python doesn't like it if you do multiple lines. Like that one's unhappy now. What if I put the dot on that line and do that? No, it's still unhappy. Darn. There is a way to split your lines and be like, hey, Python, trust me. You can put like a little backslash there, but that kind of also looks ugly. So you do have to worry about that sometimes. It'll just be a long line. But like maybe that's a cooler graph. Like that makes more sense now. I can read it better. So you can always do that to your bar charts. Histograms, of course, like it's a range that goes in order. You can't change that. And you can deal with, you have to worry about which axis to use for your scatter plots. A lot of cool things to think about. Is there any overlaid graph? Because that's something we haven't done. Any kind of overlaid graph that we could maybe do? That would be interesting. What do we have? We've got, be like, how does, for each manufacturer, again, like how does the, I don't know, the fiber compare to the sugars or something? Like you could show both of those at the same time. Like that would be a thing. Let's try that. Whee! So if I did that, that'll be the last thing we try. We've got, I probably wanted to keep some of that, actually. So if we do that weird grouping, we can get like sugar's average and fiber average. We dot select sugar's average and fiber average. And then we'll do a bar chart on just those three things. And then now we have this. Apparently there's no fiber in type A cereals, but that's all right. That's knowledge in itself. Or maybe there was some weird values like a nan or something we'll have to deal with. But yeah, it looks like they're kind of inversely related or not. It look like manufacturer N, like not a lot of sugars, but a whole lot of fiber. Like maybe they're the health foods. And then everybody else is kind of around the same range, honestly. It looks like the more you have of each, like it does make a difference. But I don't know how much we can. They don't seem to correlate that well. Is probably the word to say. But it's interesting to think about. Like, what is manufacturer N doing? Like, they must be important or different because you can see the difference between the two relative to everybody else. So that's kind of cool. That's fun to think about. And I guess that's a good example to end on. Any last questions about any of this stuff that we talked about? So just, you know how to make a bunch of pretty graphs now. Go forth and play around. And then, yeah, the last thing I want to say is it's apparently homework 3 now that goes up to this chapter. And so I'll schedule that due date while I'm thinking about it. So when is let's see, we've got something probably due today, right? Homework 7. I just don't want to double up any due dates. Or sorry, homework 3 for chapter 7. And what do we got due today? I think that's the only thing, right? We got a lab due. Well, there's nothing due after that, right? This is the next thing. So, okay, how about a week from today will be the homework? You have at least, always I'll give you at least a week to do it. That should be a relatively decent amount of time. And I think that is all that I want to say. I'll deal with that later. But I can stop the recording now.